Okay, I'm going to have a look at the summary for differentiation. Before you do anything in differentiation, all x terms must be in the top line. Never have an x on the bottom before differentiating. Also, never have any roots. Here are your rules. Power goes to front, subtract 1 from the power. The x disappears, the number on its own disappears. dy by dx means differentiate 1, and you must have this the right way around. d2y over dx squared means differentiate twice. Sometimes that's written as f dash x differentiate once, and f double dash x means differentiate twice. It's the same thing. Now, what lines can they talk about? They can ask you to find the gradient, and the gradient, see at that point, the gradient is you differentiate and put in the x value at that point. Okay? Do you see down the very bottom? If you differentiate there and put in the x value, it's going to give you a flat line. So the gradient is going to be 0. That's why we say the gradient of a turning point is 0. Right, so that's a gradient. You can be asked to find the tangent. That's the green line there. It just touches the curve. So the equation of a straight line, y minus 1 equals mx minus x1. On the tangent, the way to get the gradient, differentiate and stick in your x's, or your x. A normal, that's the pink line. The normal meets the tangent at 90 degrees, so its gradient is minus 1 over m. And do you remember what m is? M is when you differentiate and put in your x value. So, you've got your rules, you've got your notation, and you've got lines and gradient. What can I ask you then? You can ask two very complicated questions, which are basically the same. Turning points. You set dy by dx equals 0 and find your x. Sub it in to find your y. Find the nature by differentiating again and sub in your x. If that works out to be under 0, it's maximum. So it goes up to maximum point and down. If it works out to be bigger than 0, it's a minimum. So it goes down to a low point and then up. If it works out to be 0, it's called a point of inflection. And if you look here, there's a pink line. See why that's going up and then down? A point of inflection, those two turning points are merged into one. Okay, so that's turning points. You could be also asked to find max minimum. You treat these like turning points and always find the nature to check if it's max min. That's where most people will go wrong. Okay, so let's run through what we have. Question 1. Just check it there. See that x minus x2? It comes up as an x minus 2. And then power to front, take 1 off. Power to front gives you plus 12, take 1 off. And the number on its own disappears. Differentiate it again. So, where am I at? Here. So power to front, you get 20 over 4, which is 5, and take 1 off, gives you 3. Power to front, so it's minus 36, and take 1 off. Okay, number 7. Find the coordinates which the tangent is horizontal. That means it's flat. So the gradient is 0. dy by dx is 0. So in your y, would you make sure you bring that x up as a minus 1? Then differentiate. Power to front, 10 over 2 is 5. Take 1 off. Number disappears. Power to front comes plus 40 and take 1 off. It equals 0. So it's 5x plus 40 over x squared. Move your 5x over. Move your x squared over. I brought the 5. That 5 is multiplying, so over it becomes a division. Bring your opposite of cube, which is cube root, and you've got your x value. The question asks you to find the coordinates of the point. See that's in bold? So you've got your x, you've got to work out your y. So just put your x into your y equation, and that gets you your y value. And always give coordinates with x first and then y. Question 9. This is your curve. Find where it meets the x-axis. Now, it meets the x-axis when y is 0. So put y equals 0. When you're doing these, you will always be able to factorise out your x, giving you x squared minus 6x add 3. When it's an x cubed, it's called a cubic, and you're not able to solve those yet. So you will always factorise out your x to give you a wee quadratic. So factorise this bracket bit. What multiplies to give 9 and adds to give minus 6. Well, it's minus 3 and a minus 3. Put each bit equal to 0 and solve. So when x is 0, y is 0. When x is 3, y is 3. And make sure you put brackets round it. Okay, next one, turning points. The turning point is when your dy by dx equals 0. So find where you have your y, differentiate it again, or differentiate it to get 0, or put it equal to 0. Divide everything here by 3. You can either factorise or use the formula. It's easy enough to factorise, put each bit equal to 0. You've got your x point. You need to have your y coordinates. So take your x point and stick it into the y. So that's me putting the 2 x points into the y to get the y coordinates. You then need the nature, so you've got to differentiate again. If you go back up and make sure your work is clearly laid out, so you can find where dy by dx is. So dy by dx is up there. Differentiate that again, you get 6x minus 12. You've got your 2 x values. So take each in turn. Stick in 3, stick in 1. When you put in 3, it's a positive number, which means the minimum turning point. When you put in 1, it's a negative, which means it's a maximum turning point. And then you put all your wee bits and pieces together. So it crosses at 0, it crosses at 3. It turns at 1, 4, and it turns at 3, 0. And it's basically just join the dots. Question 12 is not nice. I don't like question 12 myself. You've got the total number is NA plus NB. And that's your awkward NA and your awkward NB. What I did was times out the bracket, so it's 2000 minus 20x squared plus 1000 minus 5y squared, and then tidied that up. The next wee bit there, the distance between A and B is 8. Now if you look at that wee initial picture, so x add y equals 8. So, do you see up here, you've got an equation with x's and y's in it? I can use this piece of information to get a y and put it in there. And the reason I did that was because it means that I now have an equation with all x's in it. So I've got a double bracket. I'm going to multiply it out, tidy it up, multiply it through by minus 5, tidy up, and you should get that. Now, the question then says, maximise the number. So to maximise the number, that's your turning point. So it's not dy by dx, it's dn by dx this time. And you put it equals 0. So differentiate that, disappears. Differentiate that, you get 80. Differentiate that, you get minus 50x. Put it equal to 0. You get x is 8 over 5. Substitute that into your n equation to find out what n is. But don't forget to do the nature. Lots of people forget to do the nature. Differentiate again, that disappears. You get minus 50. It's under 0, which means it's a maximum. So it's a maximum at 8 over 5 or 1.6 kilometres. Now that was a hard question, so if you're following that, you're doing extremely well. The next one, 2017, you will start to see a pattern in these. See that x3, up it comes. Don't bring the 2 up, that's a half. So bring your x3 up. Then power to front, take 1